So when we're servicing the crank, it's going to require that we remove the pedals. Panama Red here has some original rubber block panels, and these require a 9/16 wrench. I'm going to use a crescent or open-ended 9/16. Now, if you remember the rule of which way nuts and bolts turn, the old saying is righty-tighty, lefty-loosey. That applies to the right pedal. So these pedals have been taken off. They're not going to take a whole lot of effort, I don't think. This is a lefty-loosey on the right-hand pedal. And it just needs to be turned counterclockwise until it's unscrewed all the way. I'm not going to take this pedal off because I'm going to disassemble the crank assembly on a different frame. So righty-tighty, clockwise tightens that pedal. So the left pedal works just the opposite. Everything on the left-hand side of the crank assembly is what my dad used to call bastard threads. Clockwise loosens them rather than tightening. Counterclockwise, lefty, makes them tighter. So let's just take this off. We'll pause the tape. So with the bike facing the opposite direction, the left side of the crank, all of the threads run the opposite of what you're accustomed to. Rather than righty-tighty, lefty-loosey, a clockwise turn loosens the threads, a counterclockwise turn tightens the threads. So when you're removing pedals, you're going to need an open end or crescent wrench. The old Schwinn block pedals have use a 9/16. Sometimes this clearance is too tight for a regular crescent wrench. You may find on some bikes that there's not quite enough clearance to get your crescent wrench in here. This one is just fine. In a case where I can't get the wrenches in, I may resort to using my cone wrenches. Cone wrenches are really, really thin pressed metal wrenches that are made for working on the bearing cones. Those require a very, very tight clearance. And in that rare circumstance where I might abuse these by putting them on the pedals, I will double them up. And these ones in particular have two sizes on each end. And I will use those to get in there side by side, like that. You really shouldn't use these cone wrenches for anything but cones, but if you don't have the right tools, sometimes you've got to improvise a bit. So when I'm reconditioning an old Schwinn bike, I consider servicing of the crank set and servicing of the headset to be two of the most important jobs. And these are both jobs where you're going to need a specially large wrench, a wrench that most people don't have in their tool set unless they work on these old bikes. For most of the old Chicago Schwinn bikes, you're going to need a 30mm combination wrench. An acceptable alternative would be a large adjustable wrench. Looking at specifications on adjustable wrenches, generally a 12-inch, which adjustable wrenches, they size them by the length of the handle. This is an 18-inch wrench. This will go way beyond 30mm, maybe to 50mm. If you've got yourself maybe a 12-inch adjustable wrench. I think most 12-inch adjustable wrenches will go as large as 30. Myself, I think it's important enough, you know, for my kind of maybe sick involvement with this hobby. I thought it was worth investing the, I don't know, 12 or 20 bucks, whatever I spent for this 30mm wrench. Now remember, and of course this is going to make a liar of me, this is the one that where I need my 32. Yes, this is a 32mm nut, and I changed the mode on that to inches. That's the same as an 1.25 inch basically. When I went shopping for wrenches, they had the 30mm, but they didn't have the 32, so I instead bought an SAE 1.25 inch wrench. 1.25 inch, 32mm, same difference. They're close enough. So remember that, unlike the normal threads, when we're on the left side of the bike, we're not going to go counterclockwise to loosen, we're going to go clockwise. This bike has been disassembled in the recent past, so this should be a little bit easier, but I'm still going to use what we call a cheater. It's just a pipe or a tube to put on the pedal to give me a little more leverage. So I'm going to turn this wrench clockwise like I'm tightening, but that's going to loosen the nut on this side of the bike. Now, those of you doing this for the first time on an older bike, it's not going to be that easy. So when you've got this nut that will not come off with just a reasonable amount of force, many of you, if you don't do this on a regular basis, you may be very tempted to try to just apply some penetrating oil. Penetrating oil is helpful, but usually when these things are seized up, it takes more than penetrating oil. I will remind you, if you're reduced to using nothing but penetrating oil, once you've applied the penetrating oil, you may want to wrap on this lightly with a piece of wood or a rubber hammer to create some vibration. Sometimes vibrations will help that oil work in. But the real solution when you've got a really tight nut on something that's not going to come off with reasonable force is to apply some heat. Now you may want to get a full-size propane torch. If you've got some sort of a small butane torch, you can try that. I apply the heat to the nut itself. I want the nut to expand. And of course, heat is going to be transferred to the other metal parts, but this nut, if I'm applying the heat directly to the nut, I'm hoping that it will expand enough to loosen it up. If you're applying this heat after applying penetrating oil, of course be careful, don't breathe those fumes, don't start a fire. But after a couple of tries, and after applying some heat and maybe some penetrating oil, let's assume you have gotten this thing loosened up enough that you can remove this nut with some reasonable effort. Once you get this thing loosened up, it will probably get to the point where you can unscrew it the rest of the way by hand if it's not too filthy, dirty, or rusted. See how hot I got it here. When you're taking this Ashtabula crank apart, be sure you don't do anything to damage threads. I always take off both pedals. You certainly have to take off at least the left pedal because the nut is going to come off the crank. Then we've got a ring. This ring has a little tab, and that tab fits into the slot on this crank. That keeps this washer from turning, so that when you are tightening the nut back on this, this prevents the nut from turning the inner nut on the crank. The inner nut on the crank has is not a hex nut. It just has some little grooves, and I'm sure there's a special wrench. I'm sure there's a special wrench that's made for grabbing this thing, gripping it, and taking it off. I'm not buying that tool. If you're only doing one bike like this, you certainly don't want to spend the money on that tool. I generally find that I can get a screwdriver or something thin, and when this is real tight, maybe I just take the screwdriver, put it in that little slot, give it a tap with a rubber hammer or a piece of wood, and by tapping it, I can loosen it up, and then we take this inner nut off. This inner nut also becomes part of the bearing assembly. This has a taper on the inside. So again, I'm turning it clockwise. All of the threads on the left-hand side of the crank go clockwise or right to loosen, counterclockwise or left to tighten. There's my inner nut, and you can see it's got a taper. That is part of the bearing race. The next thing to come out is the inner bearing. And if I didn't mention it before, this is a job you want to do someplace where it doesn't matter if you make a mess, you want to have plenty of rags on hand. This is a fairly clean bearing because I've repacked this and re-lubricated it in the last couple of years. When you're working on one of these that hasn't been open for 10 or 20 years, this grease is just black and sticky, terrible. We want to use a screwdriver or something. I've got all these old wooden sticks that I use for delicate operations. We want to just ease that bearing out, down off. Now, this came out. You can see that the side facing us was this closed metal side. I can see the bearings here in the middle. The side towards the inside of the crank was where I can see the entire bearing. And you know what? This thing is filthy. Maybe I didn't rebuild this one. Maybe I'm mistaken about that. But we'll clean this up. I'll show you how I clean them up. That fit into the bearing race like this, and what's happening here is the bearings are what touch this. This closed metal does not touch. The bearings are riding around like this. So let's get the rest of this crank apart. I can't get the crank out till I take off the chain guard. One thing at a time. Let's get the chain guard off. So just checking, the chain guard is held on by a screw that goes through a nut, and that nut on this bike is 7/16. And there's a screw with a large slotted head. So I'm going to get my box end of my 7/16 wrench on the head on the other side, and then I've got a ratcheting screwdriver with a straight bit in it, and boy is that ever tight. That is very, very tight. I'm going to try just getting a little leverage and turning the nut first. There we go. What I'm doing here is I'm just getting the box wrench on it. Then I'm using the frame to give me a little leverage. Now it looks like I'm turning this clockwise, but of course the nut is on the other side. We're looking at it from the back side. Okay, I'm starting to get a little bit of turning of the screw. I'm going to put my screwdriver bit into a little ratcheting tool. Give me a little more leverage on this screw. You know what? It's time to use the heat. I'm going to apply some heat to the screw and to the nut on the other side as well. So after screwing around a while like a clown here, I decided to just use the Dremel tool a little more. I'm afraid this is going to be really hot. And I just was squaring off the head of the screw. Finally decided, ooh, it's a little warm. Finally decided to just cut on through. I managed to cut about half through the screw and then put the wrench and the screwdriver back on it and twisted it till it broke. That'll get the front part of the chain guard off. Let's hope the back screw's not as bad. This doesn't have a nut on it. This screw goes right into the frame. And this one's going to come out easy. The frame has a threaded hole where the chain guard mounts on the back is threaded. So I'm going to put that screw back in that hole. I will eventually replace that with stainless steel, but I'm going to keep that screw there so it's easy to figure out what diameter and what threads I need. Back in the AC, man, it's hot as hell outside. I worked up a sweat even though the Dremel tool did most of the work out there on the veranda. By the way, before I took the Dremel tool to this thing, I did put the bearings back together. Even though I'm going to clean these bearings, I didn't want to get them full of metal shavings. So, again, this inner ring goes clockwise, not counterclockwise to loosen. Always when disassembling any kind of bearings, pay careful attention to how the bearings come out. By that I mean, which way do the bearings face? This side of the bearings was facing out, this side was facing in. The more open side of the bearings was facing the inside of the crank. Once I got both of those bearings off, or once I've got the bearings out of this side, I can drop the ball bearings out of the other side of the crank and then just gently kind of twist. And of course, the Ashtabula crank is a one-piece crank from here to here, across the middle and up. That is one piece of steel. And then the bearing race and the chain ring on the other side are threaded onto this crank. These bearings again came off the same way the other side did. The more open side of the bearing faced the middle. The metal cage side faced the chain ring. And then this is a cone. The inside of these little ball bearings is riding on this cone, but that metal cage is not touching. Cloverleaf chain ring, kind I like. I'm going to just put this in here for safekeeping until I get the bearings in the degreasing solution, and then we'll clean the crank up. The bearing race that's attached to the crank, I'm going to clean it on the crank rather than disassemble that. So these pieces are going to go in a bath of degreaser. I'm going to clean them with a wire brush. They're going to go in some acetone. Then they're going to get cleaned out with a water pick and a dental probe to dig all the old chunky grease out of them.